Alright, hi everyone. So today we are in the second lesson for our topic 5 integration. So if you can recall, in the previous lesson we have learned how to integrate the function of exponential, which is in the form of e to the power of ax plus b, and we also learned how to integrate functions in the form of 1 over ax plus b. Okay, so in today's session, we are going to look at the third type of the standard function, which is trigonometry function. Okay, so we are still going to look at the idea of integration as the reverse process of differentiation. Then after that, we are going to come up what is the integral for the trigonometry functions. Okay, then after that, we will need to apply or so-called like recall all the relationships or the identities or the formulas that you have learned previously in a chapter of trigonometry to actually help us to carry out some of the integration. Okay, for example, how do you actually use double angle formula to help you to integrate a function like sine square or cos square? Okay, so for today's lesson, we'll be focusing on only one thing, which is the integration of trigonometry function. Okay, so let's look at the introduction part. Okay, as introduction, we'll do a quick revision for what we have learned previously in the chapter of differentiation. Okay, so if we have a function y equals to sine x, when we differentiate, then we will get cos x. So if you have cos x, so when you differentiate, you get negative sine x. So for tangent x, it is secant square x. Okay, and we know that in general, if let's say we have y equal to sine function fx, when we try to differentiate it, what will be happen is you will need to differentiate the fx. So you have f prime x, then you multiply with the whole function that you have with sine, change it into cos, right? Then after that you have cos fx. Okay, so now I mean, in general, it will be good that if you know how to do the general one, but then in your syllabus, right, you only require to differentiate the function of ax plus b. So that's why we'll try to do it in this way so that you can remember it in a simpler idea. Okay, so if you have sine ax plus b, when you differentiate, then what do you have? So you have a cos ax plus b, right? Because the derivative for ax plus b give you a, then you multiply with the cos ax plus b. So same thing for cos ax plus b, you have negative a sine ax plus b. So for tangent, you have secant square, then ax plus b. Alright, so now we know that integration is actually the reverse process of differentiation, right? So let's try to list out what is the steps that we actually did just now so that we can try to do the reverse so we get the integral for the function. Okay, so let's try to do it with the with the sine function. So you have y equals to sine ax plus b, right? So what is the two steps that we actually did? So the first one is we try to change the sine to cos, right? So which is actually when we differentiate sine, then we get cos. Okay, so the second thing that we try to do so that it become a cos ax plus b is actually we multiply the whole function that you have with the integral of ax plus b. Correct? So meaning that for sine ax plus b, the first thing that you do is you change sine into cos, because when you differentiate sine, you get cos. Then after that, you will multiply the whole function by the derivative of ax plus b. So now, if integration is the reverse process, right, then what is the steps that we need to do? So just now we multiply the derivative. So what is the reverse process of multiply? Then it will become divide, correct? So 1 over a. Okay, so just now, let me write down here so you can understand it. So this is how you get dy dx equal to a cos ax plus b. Okay, so now we need to change from this form back to the form that you didn't differentiate yet. Okay, so 1 over a. So cos will change to what? So before that you change sine to cos, right? So now from cos you need to change it back to sine. So sine ax plus b. Okay, and don't forget you have a plus constant. So it's the same thing now. We try to look at the sine. So for sine, when you try to change it back, then you will have the step of 1 over a as well, right? Because you multiply with the derivative also. But then when you try to integrate sine, you can see when you differentiate cos to sine, you have a negative. So that's why when you change sine back to cos, you will need to negative it as well. Okay, so don't be confused about that. So you can remember it in such a way that when you differentiate, then sine will, sine will become cos and cos will become negative sine. So that's why when you integral sine, then you should have a negative cos. Okay, plus c. All right, then the last step is the same thing because yeah, you just have second square. So second square, when you do the reverse process, then you get back tangent. Okay, so ax plus b plus c. Alright, so now let's try to look at the two example that we have. Okay, let's try to look at number 1a. So I guess it wouldn't be like very hard because what you need to do is you just reverse the process that you have learned previously for the differentiation. Okay, so maybe we can just write down. So if you have sine, when you try to change it, it becomes negative cos. Okay, so when you have cos, after you integrate, you have sine. So when you have second square, after you integrate, you have tangent. Okay, then after that, for the part for fx, you just differentiate it, then it becomes divide lah. Okay, so try to look at a. So the integrate sine 2x with respect to x. Okay, so 2x, after you differentiate, you get 2, so it become 1 over 2. So sine will become negative cos, right? So negative cos 2x. Okay, and don't forget plus a constant. That's it. Okay, b, integrate cos 3x plus pi over 2. So the whole thing integrate with respect to x as well. So it's the same thing. What is the different derivative for the function here? So 3x plus pi over 2. So pi over 2 is just a constant. So after you integrate, you get, after you differentiate, you get 0. So 3x gives you 3. Okay, then cos, you will change it to sine. So 3, and don't forget is divide. Alright, so sine 3x plus pi over 2. Okay, and then plus c. Alright, so let's move on to c. Integrate 4 second square x over 2 with respect to x as well. Okay, so the first thing that you can do is to bring out the constant that you have. Okay, so if you find it difficult, then you can just write 1 over 2x lah. Alright, so equal to, the constant stays outside as well. So 1 over 2, after you differentiate, you get 2. 1 over 2x, after you differentiate, you get 1 over 2. So when you divide 1 over 2, then you get 2. Okay, then second square will become tangent. So the function here stays the same, 1 over 2. Okay, and then don't forget plus c. Alright, so you just multiply, then you get 8 tangent x over 2 plus c. Okay, alright, let's move on to the next one. Okay, number 2, find the exact value of the finite integral. So from 0 to pi over 4, 3 minus 2 sine 2x with respect to dx. Okay, I think the first step that we can do is try to split it into two integral. So it will be much more clearer to see and to solve. So you can take out the constant as well. Okay, so now let's start to do the integration. So for 3, after you integrate, you have 3x, the range, minus 2. So for sine 2x, so when you integrate 2x, you have 2, right? So divide, so it become 1 over 2. So sine, after you differentiate, after you integrate, you get negative cos and 2x. Okay, so for the first part, you can start to substitute already. 3 pi over 4. So since 3 multiplied by 0 gives you 0, so that's alright to not writing it. So minus, you can always take out the constant as well, so it becomes plus 1. Okay, so 2 then cancel off each other. So for the cos 2x, now we can try to substitute. So cos 2 pi over 4 minus cos to 0. Okay, so please don't skip this step because I know 2 multiply with 0 you get 0, but cos 0 is not giving you 0. So equal to 3 pi over 4 plus 1. Okay, so cos pi over 2, so cos 90 degree give you 0. Okay, minus cos 0 give you 1. So I hope that by now you should be able to to actually imagine everything in your head so that you know that for 0 this is 1, and then for 90 degree this is 0. Then after that 3 pi over 4 minus 1. Okay, so because the question want you to give the answer in exact value, so you can just leave your answer in this case. Alright, so let's move on to the next part, which we try to see how do we use some of the trigonometry formula to actually help us to do integration. Okay, let's try to look at the next part. So from the previous section, we know that we can actually integrate sine, cos, and also secant square. So the question is, how if I want to integrate sine square? How if I want to integrate cos square or even tangent square? So what we will try to do here is, instead of doing like composite and so on, which composite will give you another answer, which we try not to do that. So what we will do is we will try to take the trigonometric identities that we have learned previously, so that we try to substitute the form of sine square x and cos square x in another form. Okay, so to integrate sine square and cos square, what we will try to do is we will use double angle formula. So there's one double angle formula which only consisted one time of sine square and cos square, which is cos 2x. Okay, so the first one, let's try to link it to the sine first. So cos 2x gives you 1 minus 2 sine square x, right? If you forgot, then you can try to find your handout, and then yeah. So for cos 2x, you will get 2 cos square x minus 1. Okay, so we can't integrate sine square, but we can integrate cos 2x, correct? So that's why when we have questions that we need to solve sine square x, we will try to change it in the form of cos 2x. So let's try to rearrange the whole thing. Okay, so let's try to imagine everything in your head. Okay, so sine square x will equal to, so you need to bring the 1 over there, right? Then after that you have negative 2, meaning the whole thing will need to divide by 1 over 2. Okay, so imagine exchanging this part and this part first. So you have 1 minus cos 2x. Okay, and because it's 2, the whole thing 1 over 2. Okay, so the same thing for cos square x. What do you have? So for this one, you do not need to exchange it lah, so you just bring this over there. So it becomes 1 over 2, then your cos 2x plus 1. Okay, so this is what you have. But of course, if you want to make it easier to remember, then you can remember in such a way that 1 plus cos 2x. Okay, so if it's sine square x, then 1 over 2, 1 minus cos 2x, then cos square x will equal to 1 over 2, 1 plus cos 2x. Okay, so you might not need to actually memorize it, because you can always derive it from the double angle formula that you have in your formula sheet. Okay, so the next thing is about tangent square x. So same thing, we can't integrate tangent square x, but we can always integrate secant square x. And we have a identity that we know that 1 plus tangent square x equal to secant square x. So that's why if I have tangent square, then I will always change tangent square x into secant square x minus 1. So we'll be using these three formula to actually help us to solve the next example. Okay, all right, so let's try to see a few example here. Okay, so let's try to look at example 3. So I have written down the formula here so it's easier for us to refer later. Okay, so 3a. So integrate sine square x dx. Okay, so I think this is easy. So we just substitute the sine square x here. So it will become 1 over 2, 1 minus cos 2x. Okay, so you need to expand it, or you want to bring out the constant. Okay, I think this one you don't have a range. I mean, it's not a finite integral, so it's totally fine. If you don't split it into two, then you just integrate in one shot. Okay, so take out the constant. Then after that, we can start to integrate here. So 1, you get x. So minus 2x, so it becomes 1 over 2. So cos becomes sine 2x. Okay, so plus c. So times everything, simplify your answer. So 1 over 2x minus 1 over 4 sine 2x plus c. Alright, so let's try to look at the next one. So b. Integrate 3 cos square 2x. Okay, so the first thing that you can try to do is you take out the 3 as well. So you're left with cos square 2x here. Okay, but you have a little bit problem here, which is you see in your formula, right, you only have cos square x. So how if your x become 2x here? Yeah, so what you need to do is the relationship between the x here and the 2x here is like 1x multiply 2, you get 2x, right? So meaning if your angle here become 2x, meaning that when you actually substitute, you will have cos 4x instead of 2x. So 3. So 1 over 2 still the same. 1 is also still the same, and plus cos 4x. Okay, so just like that. So the idea is that you know that, for example, if you have cos square 30, so you will write 60 here. So it's the same thing. If now you have 60 here, then what is the number that you are going to write? It's going to be 120. So that's the idea. Okay, so let's try to continue it. Now let us try to take out the constant first. So 3 over 2, 1 plus cos 4x. Okay, so now we can start to integrate it. So you have x. Okay, so for cos, or what do you get? So you have plus 1 over 4, right? Then after that, sine 4x. Okay, then the whole thing plus c. So same thing, let's try to expand and write your answer. So 3 over 2x plus 3 over 8 sine 4x plus c. Okay, so now let's try to look at c. Okay, c, integrate sine to the power of 4x dx. Okay, so for this one, you might need to do a longer step for the substitution part because you need to get rid of the sine 4 here. So sine to the power of 4. So if you were to simplify this, then you can always write it in the form of sine square x square, correct? So this is what you need to do. So we try to do it one by one, or if you want, then you can straight away so square, right? So meaning that I will have 1. Okay, then after that, the other one as well. Because sine square multiply with sine square give me sine to the power of 4. Okay, so now I combine them already. But now I need to continue to expand them. Okay, so 1 over 2 and 1 over 2, it's a constant, right? So I can take out the 1 over 4 first. Then after that, let's see what do I get when I try to expand them. So 1 minus 2 cos 2x and then plus cos square 2x. Okay, so what you realize here, you have another cos square coming in here, so we need to substitute it again. So 1 over 4, 1 minus 2 square, 2 cos 2x. So for this part, you will need to substitute again. So 1 over 2, 1 minus, so it's the same thing just now. So if you have 2x instead of x, so meaning that the 2x will become 4x. So 1 plus cos 4x. Okay, so now you can see everything is in the simplest form already. Then we can start to do the integration. So let's try to rearrange them first. So 1 minus 2 cos 2x plus 1 over 2 plus 1 over 2 cos 4x. So let's start to do the integration. Alright, so you can see 1 plus 1 over 2, then we can combine them and just do it one time. So 3 over 2x, correct? Then after that, for the next part, so 2, after you differentiate, then you get 2, right? So divide by 2, then you get 0 here, not 0, you get 1. So minus cos will become sine, okay, then 2x. So for the 1 over 2 cos 4x, so when you divide it, then you have plus 1 over 8, right? So sine 4x, okay, and then plus c. So the same thing, let's try to expand it. So 3 over 8x minus 1 over 4 sine 2x plus 1 over 32 sine 4x plus c. So that's your answer for C. Okay, so let's move on to number 4. Okay, number 4, find the exact value for the finite integral. So 0 to pi over 4, 5 tangent square x dx. Okay, so same thing, we can try to take out the constant first. So we know that we can't integrate tangent square x, right? So that's why we need to change the tangent square x into secant square x minus 1. Okay, so now we can continue to integrate it. So 5 secant square x, after you integrate, you have tangent x, right? Then after that, minus x. Okay, pi over 4, 0. So now we can substitute. So open it. So tangent, this is the first part. So tangent pi over 4 minus pi over 4. Okay, then after that, no bracket here. Then minus, so the other part, tangent 0 minus 0. Okay, so 5 tangent pi over 4, meaning tangent 45 will give you 1, right? So 1 minus pi over 4, the whole thing here, minus tangent 0 gives you 0, 0 minus 0. Okay, so we only solve for this part. So 5, you can just like expand it. So 5 minus 5 pi over 4. So because the question wants the answer to be in exact value, so you can just leave your answer like this. So 5 minus 5 pi over 4. So let's try to look at the next one. Okay, so let's try to look at number 5. So number 5, 6, and 7 is actually the combination of questions from trigonometry or differentiation together with integration. So this is the type of questions that normally come out in your exam, which is like the more comprehensive one, meaning that it's not as simple as only ask you to do integration. Okay, so for A, show that y equal to secant x, then dy dx equals to tangent x and secant x. Okay, so it depends on you whether you want to use quotient rule also can, or like the composite function also can. So 1 over cos x. Okay, so if you are using quotient rule, then you can always do u over v lah. So if you prefer composite, then it will be cos x power of -1. Okay, so maybe we try to use the composite here, then you can try out UV by yourself. So -1, the power bring it front, then after that what's inside the bracket stays the same. Power -1, so -1 minus 1 you get -2, right? Then differentiate whatever in your bracket. So for cos x you get negative sine x. Okay, so let's try to rearrange it. So what do you have? You have a positive sine x because -1 multiplied with negative here. Then the other one is you have 1 over cos square x. Okay, so you can see that it's not in the form that we want yet, so we need to rearrange it. So I have a cos square, then I can always write it in a way that sine over cos x. Then the other one is 1 over cos x. Okay, so sine over cos give me tangent, then 1 over cos x give me secant x. Okay, so this is how I prove it. And I believe if you use quotient rule, you get the exact same answer as well. Okay, so let's try to look at B. So find the exact value for the finite integral from 0 to pi over 4, and then cos 2x plus 5 tangent x secant x with respect to dx. Okay, so to make it easier, then maybe let's try to split it into two. So I have the first one, 0 pi over 4 for cos 2x. Okay, then I have the second one, which I can take out the constant. Then I have tangent x and secant x. Okay, so for this part, then I can easily integrate it, right? So after I integrate, then I have 1 over 2. So cos will become sine, then 2x. Okay, so 0 to pi over 4. So plus 5. So how about for this part? So you can see that you have tangent x and secant x. So this is, I mean, we did not learn like substitution or like the integration technique that actually allows us to do this. But you see, normally this type of question, your A and B should be related to each other. So you might need to use the idea of integration is just the reverse process of differentiation. So from A, right, actually you try to differentiate secant x and you get tangent x secant x. So now if you integrate the dy dx, what do you get? You get exactly back to x. Okay, so the idea is like y, go to dy dx, you do the differentiation, right? So now you are in dy dx, meaning you can see tangent x and secant x, which is exactly what we have as the derivative for A just now. So from here to here is the integration. So when we integrate tangent x secant x, what do we have? Then we get back exactly y, which is secant x. Okay, so secant x 0 to pi over 4. Okay, so now we can start to substitute. So 1 over 2 sine 2 pi over 4, which is the first term. Then after that, minus the second one, 1 over 2 sine 2, 0. Okay, then the next one, 5. And remember, you might need to put a big bracket because you need to include everything here. So second pi over 4 minus second 0. Okay, so this is what you have. Yeah, just put it like this. Alright, so now let's try to expand it. So 1 over 2 sine pi over 2 minus 1 over 2 sine 0 plus 5 over cos pi over 4 minus 5 over cos 0. Okay, so you can just check everything in your calculator to get your answer. So for example, then I have 1 over 2 multiply sine, then pi over 2. Yeah, this is like when you're lazy to think. So you have 1 over 2 here. Alright, so for sine 0, I think it's easy lah. So over 2 multiply with 0, then you get 0. Okay, then plus. So how about cos 45? So this one you might need calculator to help you to do that. 5 divide cos 5 divide cos pi over 4. Okay, so you have 5 square root 2. So for cos 0, you get exactly 1 minus 5 over 1. Okay, so 1 over 2 minus 5, you get 9 over negative 9 over 2. So 5 square root 2 minus 9 over 2. Alright, so that will be your last answer. Okay, yeah, so remember, if the question didn't ask for exact value, then you might need to solve it, but normally they will ask you for exact value, then you can leave your answer in pi or like in square root. Okay, so that's it. Let's move on to the next one. Okay, number 6. This is a combination between trigo questions and integration questions. So prove that 2 secant 2x tangent x equals to secant square x. So let's start with left hand side. So 2 secant 2x tangent x. So I think for us to achieve secant square x, then we might need to rearrange it. So I have 2, so secant 2x, meaning that I have 1 over sine 2x. So for tangent, we can change it into sine x over cos x. Okay, so since that the part that we need to prove is not containing any 2x, so that's why we just expand the sine 2x into 2 sine x cos x. Okay, then sine x cos x. So now I think we can try to simplify what we have here. So 2 and 2 divide each other, so you get 1. So sine and sine as well, so you're left with 1 over cos square x, which gives you secant square x. Okay, so that's the part for A. Okay, let's move on for B. Find the exact value for the finite integral. So for the range negative 1 over 3 pi to 1 over 3 pi, so 5 plus secant cosecant 2x tangent x with respect to x. Okay, so we can try to split it into two integral. So when we actually split it, then you can try to think of, then obviously you are not going to integrate cosec to x tangent x, right? So that's why if 2 cosec 2x tangent x is equals to secant square x, what if we only want secant 2x? Oh, sorry, what if we only want cosecant 2x and tangent x? So we'll need to move the 2 to the right hand side, so it become 1 over 2. So plus 1 over 2, just put it outside, then you have secant square x. Okay, so we can just write the range. So now we can start to do the integration. Okay, so for 5, it will become 5x. So 1 over 3 pi negative 1 over 3 pi plus 1 over 2. So for secant square, after you integrate, then you have tangent x. 1 over 3 negative 1 over 3. Okay, so now we can substitute. Minus 5 negative 1 over 3 pi plus 1 over 2 tangent 1 over 3 pi minus, don't forget the 1 over 2, tangent negative 1 over 3 pi. Okay, so let's try to combine them. 5 over 3 pi plus 5 over 3 pi as well. Then after that plus, so for this part you can just use your special angle. So plus 1 over 2, so tangent 60 degree give you square root 3, so square root 3 over 2 minus, so minus, yeah, you remember when you check with your calculator, you should check tangent negative. So I think it will give you negative square root 3, so that's why negative will brings you positive. Okay, so positive square root 3 over 2. So when you plus them together, you have 10 over 3 pi, and then plus pi, square root 3. Okay, so that's it for number 6. So let's move on to the last question. Okay, number 7. So if you want to try it by your own first, you can, just go ahead. Okay, A. So use the expansion for cos 3x minus x and cos 3x plus x to show the following statement. So we start from cos 2x minus cos 4x. Okay, so the question wants us to use the expansion. So for us to get 2x, you will need to use 3x minus x. Then for you to get 4x, you will need to use 3x plus x. Okay, so now you have the form of cos A minus B minus cos A plus B. So we can use the expansion that we have learned previously for the compound angle formula to solve this. So when you expand, then you have cos 3x cos x plus sine 3x sine x minus, remember your bracket, then cos 3x cos x, so this is plus, so you have minus sine 3x sine x. Okay, so cos 3x cos x minus cos 3x cos x, you get 0. So for the sine, you will get 2 sine 3x sine 3x sine x. Okay, so proved. So if you want, then you can just write it down. Okay, part B. So for the definite integral, so you want to show that the definite integral equal to 1 over 4. So you can see, obviously we can't integrate for sine 3x and sine x as well. But then just now we already proved that cos 2x minus cos 4x equals to 2 sine 3x sine x. So that's why we can always change it. Okay, substitute it. So you have pi over 4. So since you want sine 3x sine x without the 2, right? So you will need it, you will move it forward, so it will become 1 over 2 multiplied with everything. So 1 over 2 cos 2x minus cos 4x. Okay, so now we can do the integration. So 1 over 2, I think we can combine them together, it doesn't matter here. Okay, so 1 over 2, so cos will become sine 2x minus 1 over 4 sine 4x. Okay, so the range is 0 to pi over 4. So now we can start to substitute them. So 1 over 2 sine 2 pi over 4 minus 1 over 4 sine 4 pi over 4. Okay, and the other one is 0. So the same thing, please do not write 0, then after that leave your answer there, because sine 0 and cos, sine 0 give you 0, but cos 0 doesn't give you 0. So yeah, in this case it give you 0 lah. So but then just try to write it so don't you won't be doing some careless mistake. Okay, so for the front part, so 1 over 2, so 1 over 2 sine. So here you get pi over 2. So pi over 2 sine 90 give you 1. So meaning you left with a 1 here. Minus 1 over 4. So sine pi, meaning sine 180, you will get a 0. Okay, so for the whole part here, because sine 0 give you 0, so that's why I don't think you left with anything there. So minus 0. Okay, so now we can combine them together. So 0, 0, so 1 over 2 multiplied by 1 over 2, you get 1 over 4. Okay, so I think the question wants you to prove that is equal to 1 over 4. So yes, it's correct. So proved. Okay. Alright, so that's the end for the example for today's lesson. So you can try to continue to try out with the exercise. So just to let you know, for the topic of integration, because it's quite long and not all the content that you learn in P3 those who are learning P2 learning all as well. So that's why in your textbook they try to split it into two parts, which is the integration and further calculus. So meaning for this lesson we and the previous lesson we only finished the topic for integration, but actually in terms of your syllabus we not yet finish it. Yeah, so that's why you will see in your exercise you have a end of chapter review, but then it's just the first part of integration. So we'll be continuing for the next chapter content in the next lesson. Okay, and of course, when you learn the differentiation, you have tangent, negative, right? Yeah, so that's the part that we'll be doing the integration in the next lesson as well. Okay, so that's it for today's session. So please try to complete your exercise and so on, and I'll see you face to face in next week. All right, thank you.